Yes, yes.
Yes, sir.
Yes, sir. Yeah, thank you once again. I'm Benon Karara. Uh, I'm happy to welcome you here today in the training or the course for Geospatial data analysis. We are going to be together physically or in class for the next 6 days, 3 weekends. I hope you can ready. Well, there won't be a weekend this month until we are going to play when we are headed for the festival season. So,
We can't hear. We can't hear you. We can't hear you.
okay, I don't know what's happening. It normally is, but it's just fine. You can't hear me. Yeah. So, before we start, can you hear me? People online, can you hear me?
Maybe you should move close to the speaker because we can't really hear.
Holding it. I'm holding it. I don't know why. It's not, you're not hearing me, but I can others hear me. Oh, okay. Now, I would like to introduce our team that is going to help us during this training, help us navigate during the training. One, we have our lead trainer, it's called Jean de Dieu Rurangwa. He's going to make his own introduction. We explain you the experience, background, and all that. But also during the training, we have yeah, facilitators, people who help us learn. We have challenges when we are learning. It's new technology in most cases, and this is a practical class. So when we have these practical classes that are not about technology, we have people who facilitate that. They assist our training. These people, their main role is to help you navigate in the training. So when you have any challenge, just raise up your hand and then come to your laptop, help you through whatever that is challenging you. Right? So those people are published between them and Grantad and Benjamin. Benjamin will mostly be working with people online. So there's someone called Benjamin in your class. The people are online. He's always there. You can write in the chat box, in the Google Chat, in the Google Meet. You see if there's any of the questions, or you can speak up and the trainer will be hearing you and he will address your question or any challenge that you might be facing. People who have been in the classroom, at least for yesterday, Friday, have seen that we shared a link to the Google Classroom. Are you all on the Google Classroom? There is a link that we shared yesterday on Google that takes you to the Google Classroom. Access where they must go. Not in your top. Your top group is for communication and everything, but the reading materials, the exercises are also. So please, if you haven't joined the Google Classroom, join it. And because that's where even when you have exercise, and they are and people. That's where it works. You don't send it to someone's email, you don't send it to a platform or WhatsApp for someone, you send it to the Google Classroom for right? Yeah. Also, another thing that we should like to communicate is that the training is being recorded. Before it, before the training, the focus on review. After the training, there are some things that you might forget. There are some things that you might. There's a difference between yesterday, not in the morning. In the morning, they sent a link to the Google Meet. But yesterday, in the announcement, in the main announcement, you have something called Google Classroom. It's not a video conference, it's a repository. Yeah. So, what about that? I was talking about recording. So we record the session. As they go on, they are also being recorded. As the trainer explains everything, they're also being recorded. So after one day, like today's session is going to be posted. So there is some cleaning that's this. So it will be posted tomorrow in the Google Classroom. You can access it anytime after the training. Yeah. That's its purpose. One last thing, and this is very important. Please pay attention. I hope we are together, and I hope we are together for even before time. We have a practice in our program, this professional program, that after the training, final capstone project is the final assignment work on individually regarding the course. And this is what qualifies you for the certificate. It's not participation. It's not attendance. It's that final capstone. It's not like that. For example, you sit here and work on it. But this one you take it. Work on it for 2 weeks after the training. And it's all about what you learn from the lessons that it's practical. It's a project-based assignment. And you submit that, the trainer reviews your work, and from your work, you give the or merit that you completed this course. That's how we do it. Why? Because there is a certificate, but then there is the practical skill that you gain. We spend here 6 days, 3 weekends, without any rest. We can expect that by the time you come from this course, we have practical skill that we can show that you really know what to do in this scenario. So, the assignment is a practical form of the exam or evaluation of the skills gained from the training. I interesting. You are having someone skills in the special data analysis, right? Then you have 2 people. One of them shows you a certificate. They are written as a type. And the other one shows you a project in your form. The shows practically show that they have a certain skill. If you were the one hired, you would use something. The person with the project. That's the sole purpose. It's not making people run things. That's not the purpose. It's good to have something that you have. So you can always access that project anytime. You can improve on it. You can do whatever you want. It's your project. It's your intellectual property. But we want you to have it as a proof that you have it. That also builds our confidence that even the trainer deliver what was expected from you. Yeah. Apart from that, what's happening with all of us in this? I hope you'll have interesting lessons. You're going to have an opportunity to network. That's also part of the purpose of the course. And you can see from this Zoom, even people online who might not show up today but may show up tomorrow, we come from different institutions and different locations. We like to know who your neighbor is and what they do because we know each other and we may as well to get the opportunity to also share opportunity. So apart from that, I'll give up to our trainer. He's going to lead us to the content days and maybe you also did answer the introduction. Yeah. Thank you so much.
link. The people who are online can see the PPT, the presentation. Can you confirm?
Yeah,
Someone
yeah.
can- Okay, thank you. So today we are starting the first session of professional training on geospatial analytics or geospatial analysis. We will have 6 sessions or 6 days where we'll be covering different topics about geospatial analysis. So I want to welcome you if it's your first time to join the Data Plus training, or if you are the first time to learn about geospatial technologies or geospatial analysis, I welcome you. So me, I'm Jean de Dieu Rurangwa. Going to show you like my background, but first I wanted to that while I'm explaining my background, we will also have to fill the form. So the form is just a template to get to know where you are, what is your current status with the GIS or geospatial technologies. So we'll be using the link here. You can use your phone to scan it, or if you don't have access, I can give you the link to access the form. So meanwhile, we'll come back to this one. I want to first give you my few backgrounds. So the easiest way to give you an introduction is to use my LinkedIn. So currently, I'm the technology manager at SP Rwanda. If you have known about SP, it's a GIS tech company, but more involved in geospatial technologies. So currently, that's my job. I have, let me put a magnifier so that you can see. So since 2024 till now, I'm the technology manager at SP Rwanda and had my research about my master's in Spain in 2023, 2024. I was a graduate student at the University of that is in Spain and Germany. But before I was a GIS specialist again from SP Rwanda since 2021. My education is here. I had a background in my master's was in geospatial technologies, as you can read. But I had a bachelor degree in city and urban community and regional planning at the University of Rwanda since 2021. So that's my main background. And related to the GIS, after the courses, we also sometimes take some certifications. So most of the certification I have worked for is for the S3, like Python scripting, suitability analysis, visualizing using Python. Like I have taken a course on using the UN datasets and being part of the UN mappers. I also have this is an international recognized certificate for GIS professionals. So if you have such background, you have like the basic knowledge about using the geospatial technology. So you can search me on LinkedIn and you can contact me, or however you want, you can reach me out. So I'm by the names of Jean de Dieu Rurangwa. So that's even my job. I do it on a daily basis using GIS and other data scientific technologies. So now back to you. Scan the form, the QRM, and fill the form, and you will see like your main interest in the training and also your current job Carry on. I've shared the link in the Google Classroom, the Google Meet with a link. I'm also going to share it on the WhatsApp group if someone has no access on it. Everyone is filling the form. So the first question is about your current job, can be even a student, and then which sector best describes your work, like, what's your actually your industry. Uh, to understand your knowledge about GIS, we usually have softwares. So which one of them have you used? And on a scale of 1 to 5, how often do you currently work with location data? Like, have you ever used, or you have never used the data, the location data? The other question is about why you are attending this course today. Is it a requirement from your job, or is it an interest, or you want to work on a specific project? And then if you have a specific topic of your interest you want to know more about, or a project, you could even give a description or a short summary of it, or just a name of a topic you want to learn about or work on. And then if you use the data, what data are you mostly currently using? Is it like spreadsheets like Excel? Is it GPS points? Is it imagery or any other type of data? And then what do you hope to learn from this training? This is the questionnaire. Tell me if you don't have access, I can maybe send it to your contact, or so to access it, I have put the link, or you can even scan the QR code. Let's get maybe more 5 minutes only. So I have so far 15 people who have submitted. Have 20 more. We have 20 people already submitted. You can scan the QR code here on the screen. You can use the WhatsApp group. There's also the link. There's also the link shared on the Google Meet. Only 3 minutes left. One minute left. I think it's time. Let's refresh for the last time. Okay. So we have 28 people submitted, and then I think it's most above the half of the people who are attending. So we have more people in the student category and researchers. We also have data systems specialists, environmental, we have managers, we have engineers, officers, researchers again. You can see assurance, project management, administrative or administration, design, network, business. We have scientists. I think most of the submission are here. So we use this information so that we can align with the say that we use this information to find a way of creating content related to your interest, to your background. So we try to cover different topics related to your category. Let's see. The second question was the sector. Again, we have a lot of people in agriculture, either studying or doing research or doing the normal jobs. Agriculture. We have also people in the healthcare sector and education. Again, infrastructure. And these are the main big industries consuming or using the geospatial technologies or GIS data. You have also people using public like such tool, like this tool of surveying, collecting data or managing public data. We also get to know more about any of the the big topics. And then on the tools, we had three: ArcGIS, QGIS, and Google Earth. So I can see that most people use Google Earth or have like the basic knowledge of using Google Earth. We also have people using app like ArcGIS. Yes, who have used ArcGIS. I can see you are using Q or have used QGIS. Do you know QGIS? So it's like another software using or consuming GIS data, or you can perform different analysis using GIS data. The Google Earth is a platform of almost online platform for consuming mostly the Google satellite images or Google models for performing different analysis. And for ArcGIS, it's also a desktop software where everyone just normally navigates to put the data on the map, create a layout, or perform any kind of analysis. So we will cover the two, the Google Earth, and we'll use mostly with the ArcGIS. The QGIS, again, it's an open source. For anyone who wants to learn about GIS more in details, you can find QGIS. It's an open, it's just something you download and then you start to use on a daily basis. On the ArcGIS, normally you have to have a license to use it. So for this course specifically, I will share you my credentials so that you can start to use the ArcGIS platform. But we have two versions. We have what we call ArcGIS Pro, which is the current version being used on the market. And we have the former or the traditional software, which is called ArcMap. So ArcMap is also somehow open because most people have class. What we call class is like something to use without permission. You don't have a license for it, but still you can use it. You can use that one. But for the ArcGIS Pro, you definitely need a license for it. But you can still also have what we call students account. Mostly you perform the basic analysis using the ArcGIS Pro licenses. So on a scale of 1 to 5, how often do you currently work with location data? Most people, it's occasionally. We have 6 people who have never used it. Like have never used geospatial or geolocated data or location data. Some are rarely, 6 also. We have few people, only 1 who use GIS on a daily job, and 4 who are using it like on a weekly. So like the major category is on occasional, like when you have like a project or you have an assignment where you have to use location data. While you're attending, most of you is an interest. 27% of it's almost 50% of the class are using are attending this course for their interest, which is really good. A specific topic or project in your mind? This is where we start to get to more in details, like what is your interest? Some are in data, some are in monitoring, mapping, analysis, management, transport, risk, like risk analysis, site, suitability, hope, and program. So the question was, if you have a specific topic or project in your mind, what would it be? Like showing your interest. And then again, the data you normally use are spreadsheets like Excel files or other table data, which is also common. And GPS, sometimes GPS are not in a file like an Excel. Sometimes you have to put it on the map so that you can see the data you have. So the most people who say imagery is because they use the Google Earth or they use the ArcGIS to visualize satellite images or perform analysis on satellite images. But I can see that most of you have used or you are currently using spreadsheets. Yes, this is a big question also. What is the one topic or one specific thing you want to learn from the from the training or today? Most of you said about data. It's the word that kept coming and what you submitted. Again, geospatial or analysis, what we are going also to cover throughout the 6 days. You can see GIS, spatial map, yes, creating maps or layout. You can see Google analytics, ops, and different other naming. Yes, this was the last question. So if you have missed the link, you can still access the link so that we can have your view on the interest of the training or what you want to learn from this. So back to the first or the second question. I'm going to ask you, like, tell me, like, in few words, what you normally do. Like, I have seen that most people who are using agriculture or in the agriculture sector, what do you normally do with the GIS? In the agriculture sector, let's like people focus on agriculture. What do you Where do you use your GIS data or the spatial data or location data? What you have evidence GIS or spatial information on the agriculture? Anyone? You see that most people say let's see the comments. Number 4, it's only 4. Don't feel like doing. Some people say they are currently working in whether industry or they are specifically they speak in agriculture. Then the one who can say is my name is John de Dieu Rurangwa.
So, really good stuff.
Power on.
So let's start very quick. For today's agenda, we are going to cover mainly 4 parts. So we are going to start with the introduction, where we present you like a demo introduction to geospatial analysis, or people who have no idea about geospatial technologies, and we'll we'll show you show you how to start installing the software that we're going to be using the training. And again, I will share some data we'll be using and start with the first exercise of adding the data to the map. And then from there, we'll have a break. From there, after the break, we will do a second demo about vector and raster data. These are the common data we use in GIS. We do an exercise on stabilizing those data. We take lunch, and after lunch, we will have two other sessions. One is about coordinate system, and then another one for creating the layout. That's what we are going to cover for today. So mainly, you need to have a laptop to start with this course, because what we do normally needs more practical sessions. So you need to have it at least working, and I will show you how to install the. I think that's what we are going to first with. I will give a small introduction, and then from there we'll start with the software installation. So GIS. While talking about GIS, we mainly have those 4 key terms: the capturing of the data, analyzing the data, managing the data, and presenting geographic data. So when you hear about someone telling you about geographic or GIS, geographic information system, those are the 4 keywords we use. Either someone is just capturing the data, or someone has already the data and they are starting to analyze them. The third one is managing. You might have not just one area, you might be covering a whole country, a whole region, like a big area. So you need to, or you might have a large data set. Not only maybe if you're talking about, for example, the mining example, you're not talking about only the mine sites, you're talking about where people are, you're talking about infrastructures, you're talking about other environmental data that might be around. Those data need to be managed. So some people have just knowledge or skills on managing only things. It can be your current job, or you can be even do it on your daily basis. Even capturing, some companies only do capturing data, like the Google Earth Engine or the Google company. Normally they capture the data and then they give you access to those data, like satellite data. Some other companies do, or specific people or projects analyze those data, only that. They might have already the data in the database, but they hire you, or you have the job to analyze data and provide solutions. Some other people might just be using it to present, just creating a final output. What do you want to show on a map? Or what do you want to show as, like for instance, if you have used an example of a GIS presentation app, when you use Google Map, when you use Move, when you use any application that requires you to put in your location, that's when you're starting to do. If you are the one who are providing the tool, or you are providing the application, you are trying to give a user the data, or you are trying to present the data in the format of a mobile application. So when you are using such data, someone has done a job of presenting the data to you. So that's what we have mainly captured in geographic data. And again, we are talking about only geographic. So geographic mainly means the location, where you are compared to your surrounding. So if I'm here because I'm far from here. I'm from maybe the other regions. So the reason you put a location is to compare your location from another area. So that's why we use geographic data. And those geographic data, we normally give them what we call attributes, information. A location cannot be understandable when you don't give it information. When I say I'm located here, I have a symbol. saying that I'm located here on this value, on X and Y. That's what they usually say. On this number and this number, when they are combined, you have a location, a specific location. So geographic data you will see some people talk about spatial data. It's somehow similar to geographic data. The only difference is that they have different differences. That's what we are going to see in the next slides. So this is what I was explaining. You call something a geographic data because you can visualize it on the map. If you just have it as a number, or you are not assessing it compared to the other regions, it would be just a normal data, like a data as a table. But when you add a location, you add a location on the map, on the something based on. So that's why we call it geographic data. So it can be a building, it can be any other type of information. When you give it a location, you add it on the map, and then you have its information. Adding on the geographic data, you might add information depending on what you want to represent. So we add information on the map because we want to represent what we are locating. If it is a building like that one, you might add information of its height, its length, and whatever information you want to add. Maybe the number of floors, the number of windows, whatever you want to add on that location, you add it on the geographic position. You can add information, most of it you will see information about the size. If it is something of a line, like a road, you might have its length. If it's something of a shape, like a building, have a shape, you might have the area of that specific geographic data. So these are the main information we add on geographic data. So here they are showing some of the information you can add on geographic data. So for instance, on this example, so this is a building, it has a location, but you want to add information about the name of the building or the residence. You want to add the number of floors or the number of rooms. You want to add the number of people living in that building. So when you have such information aside on a table and you have a location and you combine the two, you can now call it spatial data because it doesn't only have the attribute information, but it also have like the coordinates or the geographic information, which you can use on the map, but because a location is not important as long as it doesn't have any specific or additional information. So whenever you see the data, most people don't even focus on the GIS or the geographic location. Most of the people are interested in the additional information on the location. So those additional information are what we call attributes, but they play a key role as the location. So the location, you can perform any kind of analysis you want, but when you have also such information, you have a full data set that you can use in your analysis. So as we saw, we had
I can say that the spatial data is like the traditional distribution. So the distribution by completing the location. The geographical data is only the location. And the spatial data is in case there is an additional distribution that
even spatial data they should have a geographic information. But on addition of that, you have to also have like the attributes on that feature or that layer. or specific information. So that's the two differences. The geographic is just the location. But when you add additional information on that location, that's when it becomes spatial data. Yes. So let's see the main, but I have also talked about it. The GIS processes. So you might be interested in just capturing data. Capturing, it means going on the ground and taking information or using any specific tool to capture information. Like a drone can capture GIS or geographic information. A GPS device, which is a small device like this one, and then you can capture such information, or you can even capture information using just your hand. You have a map on your screen, and you want to just draw. I want to draw an area, maybe a boundary. You can capture such information. We'll see different ways of capturing, and then also see how to analyze and manage and present the data. So capturing, normally we use GPS to capture the information of the location. So a GPS, a global positioning system, most of our phones have such capacity of recording the GPS information. So the GPS information is just X and Y. This is X and Y. What I'm talking about is the longitude and the latitude. So everywhere on Earth, there is a system where you are located. If you have a phone and you are located here, there is an already built system that will tell you where you are located. So this already built system is what we call a coordinate system. So people have set somewhere and then they decided how we should represent every location on Earth. So when you use a mobile phone or a GPS system, it can tell you where you are located, but it tells you where you are located based on this system, what we call a coordinate system. Some other call it geographic coordinate system. So sometimes you have to learn about this already built system to understand what you are going to capture, what it is going to be based upon. So if you don't understand the system, how it works, you might not understand where the data is captured. So the geographic coordinate system, it's a system composed of what we call datums. It's a way of representing the Earth. And then there is a way of showing the Earth on a flat paper. And then on a flat paper, they can now decide on, based on the location you are located in. This is from the center, you are located from here. And from this line, normally this is the Y or the longitude. And then you have the X, which is because the latitude. Normally they call it equator, if you remember. And then this one is called the Greenwich meridian. So that's the Greenwich meridian. From here you can think of it. It's based on a specific with other Greenwich meridians, depending on the system being used. So you'll see some examples, but the most known is the one which is Greenwich, but the equator is always the same on different systems. So the coordinate system is the one that is being used when we are capturing the GPS records all information. So the GPS gives you just two information. Sometimes it tells you that you are on 30 degrees, maybe 20 degrees east, and maybe 2 degrees south. What does it mean? From this line, you are 30 degrees east. So you have the west part and the east part. On the east part, you are on 30 degrees. So maybe this is 10, 20, 30. So you are on this line, 30 degrees. And then they say you are 2 degrees south, the south from the equator. So you count, maybe if it is 10, and then from 0 to 10, which is south. If it's north, you are above the equator, and you are located just right here. And then that's what the GPS does. It gives you just the two information. So after capturing this information, you might want to perform any kind of analysis, or you just want to give it to someone. Like for instance, when you're using the Google map, it asks you what is your current location. But when you're sending the location to someone, that's what you are giving him or her. Just giving him this information, and then when you give this information to someone, they can see where you are located, but they see it based on the map. And then based on their location again, they can see where you are from there. And then they show you where to get to their location. So some industries sell this information just to give you a direction to get to someone. But they just based on the two information, where you are located and where someone else is located, and then they do some algorithm on the routes, and then you get the direction to get to your destination or to the place you want to go to. So this is the first way of filtering. Oh, the laptop. Try. So another way of capturing geographic information is to either digitalize them or to georeference. So when we talk about digitalize, let's take an example. Google Maps. So first, let's search here. Muhabura building. This is where we are located now. So this point, which has a specific geographic information, when you right click, you can see the two numbers. One represents the X and another one represents the Y, which is the one we are showing here. So these are the kind of information being shown on the map, but they use such example as a marker on a map, but a marker is it's under information is this kind of information. So someone has recorded this information, Muhabura building. Someone has already captured such information. But what they have captured is the name plus its location. So you can search the name on Google, but to see it on the map, you have to have the two information. So these are the kind of geographic information we are talking about. So that's a way someone can record it. So either using a GPS, I said it's something as a mobile device where you go on a location, then capture such information. But you can also use this second process called digitalizing. So when you are digitalizing, you are creating a point by yourself without using any device. So you first create, or you first see where you want to locate or capture, and then you create a point. So when you create a point, you are creating a point by digitalizing. Digitalizing means like creating your own information. So for instance, I want to locate maybe this building. It has no name, and I want to say this building is maybe called Muhabura Restaurant. So on Google, there is a way of creating a specific point on a map. But when you are creating such information without using a device, you are digitalizing. You are creating a point. So another way of digitalizing is not only just a building or just a point. You might want to draw this line. You see? Maybe this is a road, and you want to create such road. Sometimes you don't have a satellite image, you have something like this. So the people who have created such similar, what we call base map, they have manually created such lines. Or they have created lines based on the satellite image. But there is some models behind to capture such information. But normally, when we are talking about digitalizing, you want to create a similar thing, but you are basing on the imagery. So you want to create something as a line or as a point, you will see it, or as a polygon. Like you want to draw like a building footprint. That's when you are talking about digitalizing. Is it clear before moving? The difference between digitalizing and capturing data using the GPS. And then georeferencing. So georeferencing, it means you have like an image, but such image doesn't have, or such location doesn't have the coordinates, the X and Y, but you have already the image. For instance, the one we are using here. Someone gave you like, if you have seen any example of a drone image, they might capture a small area, and you want to put that small area on a map. So when you are trying to put it on a map, you do what we call georeferencing. You want to put the data you already have on a map. So when you are trying to put it on a map, you do what we call georeferencing. So how do you do it? Because you know the area, you first say at the border of this image, I want to capture the X and Y of this point is here. The X and Y of this point is here. The X of and Y of this corner, if it's an image, is here. And the X and Y of such image is here. And then you use a tool or something of a model to use those already known coordinates and the image you already have, combine the two, and then it applies it and it creates a new geographic information. Have anyone done any georeferencing before? Can you give us an example of where you have used it? Oh, okay. That's really good. So, for instance, let's use this example. You see, you might have an area like this one, and you have already maybe someone has already drawn something like this. And then you want to put it on the map, but when you put it on the map, sometimes it fails or it goes somewhere else. Maybe it comes to this side. And you know exactly that it should be on this side. So the data is already visualized, but it has no geographic information. The main thing has lost its geographic information. So what you do, you normally first draw the corners of the image or the data you want to put on the map. And then it's like taking the map you have here and try to invest it in this area. And then we tell that the model or the tool that it should not go beyond this area. So it tries to put it on the map. But while trying to put it on the map, it is doing what is called giving it the reference, with your reference. It's like giving it the location, the exact location. It has a specific example of the request. That's the third way of capturing geographic information. Another way is to use remote sensing. Normally, examples I was giving, this is a remote sensed data. This one. The whole world was captured, but it wasn't captured using either the GPS device, it wasn't georeferenced, it was captured using a satellite device. So you normally hear that people or countries send satellites in the sky, and then this is their job. It's to go in the sky and try to picture, just like taking a picture of the world. So when they are capturing it, they give us such information. But there are other types of information they are captured, not only the satellite images like this one. There are other types of information they capture. So normally we have two types of devices. They are the ones they call active and passive. The passive, starting from the passive, they only capture information when there is another source of light. So for instance, using your own camera, I want to capture anything using a camera. So on a daily light, so this is the source of the light. That's the example. When I'm capturing this bottle, I'm using the light that will capture the bottle and then see the image on my phone. But when they turn off this light, I can't see anything. So I'm capturing the information not only because of what I want to capture, but also because of the source of the light. So that's a passive type of device they send. So they normally use the sun as their source, and then they try to capture the globe. So another one which is called active, which has its own light. So that's the example using of a phone. So when you turn on your flashlight, let's see. Yes, you want to try to capture the object, but you have your own source of light. So this is a kind of another device capturing again the geographic data. So it has a similar capacity of a phone. If it has its own source of light, it's called an active device, which captures again the similar object on the ground. So sometimes it's not only, as I said, it's not only satellite data like this one, but some devices captures information even underground. So such device need to have a capacity of even penetrating the ground features. So if you have such capacity, or if the sensor has such capacity, it can capture below the ground, which are the examples of active. Active has some particles or some capacity of having light that can traverse an object. So you can hear about, for instance, like satellite images that can capture the capacity of the soil. With our eyes, you cannot see if a soil, for instance, has enough water or doesn't have enough uh, nutrients. But there is an instrument that can have such capacity because it has the capacity of reading information other than the ones that are in the band of light what we normally see as humans. So such sensors, when they are in the sky, they can capture such information and then provide geographic data. Before moving on, we have seen 3 ways of capturing data using the GPS, either digitalizing or geofencing, and also using remote sensing devices. Even drones capture similar information. The drones are normally a device that has a sensor. The sensor is like a camera. A sensor that can capture such information. But a drone is just a device that is able to fly. But you can't, if you want to capture GIS information or geographic information on such drone, you attach a sensor that will capture such information and gives you or put it in the memory, either its own property, or it can even provide such information on another device around. Any other example, other than the 3? You have a GPS, another way is digitalizing and georeferencing, and then using remote sensing devices. Yes, the one for the drones, they use photogrammetric techniques. So
What about those that are able to penetrate? And there are new technologies. I don't know if I can call them new, but there are technologies that are used to, in surveillance, they are able to detect the activities undergoing in the tunnels underground. What tools in those categories are?
So we normally use the term sensor. It's just a sensor. But when a sensor also captures the location, the X and Y of where it's happening, that's when we add it in the remote sensed. It's something sensing information, but in a remote area. It's not on the ground. So when we say about remote, it's something as like far from the ground, and it is capturing such information. So a sensor, for instance, let me give you an example of a similar sensor. In the utility infrastructures, utility, it means electricity, water, similar things. So sometimes they want to know if electricity is passing for instance, in a pipeline. But the sensor capturing such information, it doesn't record such X and Y, the geographic location. But a sensor can capture such information. The sensor just, it's like an instrument that's able to capture information of something happening when it is like throwing rays. So a sensor is similar like a light, the one I was giving an example. So a light, when something passes under this light, it captures such information. So a sensor can send information like the ones when you see lights turning on and turning off, they are using sensors to just, if something is approaching, the light turns on. So it's a similar way. But when you want to capture similar information and add the location of such information, that's when we talk about the remote sensing capturing GIS data. That's only when we use it. But there are different types of sensors that just capture the normal information, like the one you're giving example. But sometimes industries try to find also, if they're interested in the location, they add such capability on the sensor. Yeah, that's the way I could explain it. But if they are not interested, they just keep the information being recorded. So on the second step, analyzing, we have captured the data and want to see some types of analysis. So
Yeah,
when
sorry,
you
sir. Excuse me, I have a question.
yes,
Sorry to cut you off because I raised my hand, so I thought maybe you didn't see it. I wanted to check if we can capture data from modeling, like if we use the known details to get the unknown. For example, if we already know that we have the information about this location and we want to capture the next location, but we don't have information, can we categorize that as under capturing or analysis?
the unknown data. Can you
Yes.
give me an example of the unknown data you want to like to capture? Like an example.
Okay. For example, we want to monitor the growth of vegetation in a location, and then we use information regarding the data that's already been collected, and we use it to let's say we use it to model and just get for us to get that result for the particular locations, because I'm not really deep into this, but I just have the surface level knowledge about, okay, we can use modeling to get data and information from the things that we don't know yet from the one that we already know. So is it like a form of capturing data, or it's just analysis straight away?
So the one asking questions on the Google Meet is asking if you have already data you have collected, like known data. For instance, was giving an example in the agricultural sector where you have, for instance, records about plants you have planted, like a vegetation area, and you only know what you have planted, but as plants, they grow, and you want to understand their growth. What kind of, but you don't have such information. It's something you want to analyze, but you don't have similar information. So there are some types of data. As I said, an example is satellite image data. There are other types of data that are specifically related to like soil data or agriculture data. When we talk about like the NDVI, so you combine information captured from the sensor. So a satellite image normally doesn't just capture what we call the RGB. The RGB is the one we are actually seeing here on the map. So the RGB is the red, green, and blue. It's because we can relate to the satellite image. When you look on a satellite image like this one, you can see that there is a plant, there is an area planted, and there is an area which is built. So to such similar information is an example of an RGB satellite image information captured. But on a I don't remember when, if you remember when in what can be captured from the light, we have a range of what we call, is it light, the RGB, and the spectrum. So there is some other information that are captured using a satellite image, which captures information that we don't normally see. So these are what we call normally bands. Bands, the RGB band or the ones for the light are normally the ones recording the red, green, and blue lights, but there are other bands like ultra, the near infrared, such information. So such informations are the ones that are being used to now capture what you are talking about, the vegetation growth or the vegetation indices. So you combine different bands. It's in the part of analyzing where you combine different information captured from the satellite, and then you can now start to see those indices showing the growth of something else you are interested in. Is it clear?
Yes, sir. Thank you.
Okay. Good. So, continuing on the analysis part, examples. These are examples of what you can perform using the data you have captured. For instance, the slope and the aspects. So when you have captured what we call elevation data, normally we call them the digital elevation model. So when you have the elevation data, you can analyze and show where areas are steep or gentle, like the slope. When you have the GPS record, like that one of 51, 28, 38, you can do what we call geocoding. It's trying to find the location compared to the address. An address is different from a location. When someone asks you, what is your address? It's different from asking you, like, what is your location? The Google map, let's go back again. So the location of this point on the map, it has such values, but this is not the address of this area. So sometimes the address is the similar example of what we have in Kigali of KG, maybe 018, what? ST. So this is an address. An address, it's a pre-configured, it's something people have just created on their own, and they decide that this road should be called KG and whatever number they want. That's an address. So there is a tool in GIS that transforms your location, what you already have, into an address. But you transform into an address when your country or your regions you are in already have an address system. That's what we could give an example. So in Kigali, we already have an address of where everyone is located compared to their road, to their nearest road. That's an example. So when you have a location and you want to find its address, there is a tool. That's what we are starting now from the analysis that will transform your location into the address. So we call it address geocoding. That's an example of an analysis you can perform when you have already the data of a location. But you also can perform any other. There's a lot of analysis you can perform using the data captured. So we are trying to give you like an overview of what you can perform using GIS or what you can do using GIS. But we'll go in depth when we are starting to go in depth with the courses. So while analyzing, you normally use different platforms to do such analysis. Normally, people use ArcGIS. You can also use the Quantum GIS. That one is Map Info. And there is also other many. The Google Earth Engine is also another source of platform where you can start to do the similar analysis. You can use, if you are a programmer or you have knowledge about programming, there is Python libraries that are capable or usable to perform similar analysis when you have GIS data. So normally the two ArcGIS and Quantum are the ones that have already used, and they can perform analysis you want to do. Because the technology is evolving, most of this analysis is no longer being performed on a desktop. Because desktop are limited on the spaces, we are now moving to the cloud space, where you perform any kind of analysis and you store your information maybe on a Google Drive. That's a similar example you can think of. But if you maybe are working in an industry where they are requiring you to use the desktop application to analyze the data, you will use the desktop applications. But as I said, the technology is being evolved, so you will need to learn about also the cloud-based platform to analyze GIS data. And most of it is free of charge. If you want to learn, if you want to start using it, most of the platform are free to use, and they can perform similar analysis you do in ArcGIS or any other desktop application. This is the step 3. We've seen some example of how we can analyze GIS data and what kind of solutions or software we can use. There's also a part of managing. So managing is an already industry aside some GIS. So you normally store the data either on your laptop in a folder, or if you have a server or a database aside, you can store such information. So when you want to save or keep your information that has the location in addition, other than just the table, you use also different sources like PostGIS, MySQL, Oracle. There's also the ones for ArcGIS like a geodatabase. You have the one for Google, which is a KML. You also have what we call GeoPackage, depending on what you're using. These are the kind of example of storages you can think of. The list is extendable, but these ones they have capabilities of storing not only the table information, but also the location. Location also is kept in another format that we will see later. So managing is also another component of GIS where you store information. So imagine you are maybe a city engineer of any area, and then you have like thousands of data sets you want to keep. So you might want to hire someone who will just manage the data. Just managing, keeping the data in the database and updating them. It's also a heavy work that is being done in GIS. And then lastly, while presenting, we have the traditional way of representing the data using printed maps. Most of areas you will see somewhere someone has printed a map showing locations on the map. But there are also new ways of presenting data, either using an online platform or a cloud-based platform by storing what we call dynamic maps. So a dynamic map is like the one we have here in the example of the Google map. A dynamic map means you can zoom in, you can zoom out, you can do a query, you can search. So this is a dynamic map. But when you talk about the static map, it's something fixed. You cannot do anything. You need to zoom in using you can't do anything. It's something which is static. So most of the printed maps are static. And now we are currently all have already evolved to use dynamic maps where you can move anywhere you want. You can perform any query or analysis from the map, or you can even add more information on the map. So that's where the GIS is evolving to. We are evolving to use dynamics or content that can be dynamically changed. That's where we are heading to. But depending on the needs, again, you can still use printed maps. So printed is something you can print out from your machine and then maybe print it somewhere or paste it on a wall or somewhere else. So where is GIS being applied? So GIS is being applied in different areas. I will be giving some small examples of how it's being used in different areas. We can start from the above. I'll be giving an example in Rwanda. In the land management, we are using spatial data or geographic data to manage parcels, UPIs. So this is an example of where the GIS is being used. So when you go when you search on the browser and search for the city of Kigali, for instance, master plan, it's an open platform. We have, if you know or you have a specific UPI, may increase the size for the short. You can search your own UPI. UPI, it means the parcel boundary or the plot boundary. This is an example of geographic data. It's located on a map. It is already captured. You just type your number or you just type in your street, which is the address, for instance, 477 ST. Let's search for maybe hello. And then they would direct you to your area of interest. So the small polygons you see are parcels. So when you type in here your parcel, you'll see it on the map. So for you to have such information, the city of Kigali has done the work we have explained. They have captured the data, they have analyzed, they have managed storage this data somewhere on the server, and then they have created an application for you to use. So they have done the 4 processes of GIS, so that you can see the final result as a dynamic map. So you can still sometimes, if you go on the sector offices, you will see sometimes they have created what we call a printed map. They have fixed it somewhere. Whenever you want, or you have knowledge about using it, you can go still and use that printed maps. But here it's an example of the work done by the city of Kigali, passing through the four steps. So, for instance, let's start from how they have captured this information. What kind of data do you see on the map? First, we have what we call this is a satellite image. How was it captured? Using what? Satellite. Yes, it's a remote sensing. So they can capture it or they can buy it. It's something you can go and buy. You can go and buy. Similar example. For instance, here they have bought it where this is the place. They ask Star Geographics. This is mostly the company selling satellites, and then they have used the S3 platform to develop such application. So they have bought or they have already the satellite image. So the satellite image, if it is a service, the service, it means you access this satellite image not from your own storage. So for instance, what kind of service can I give you? It's something you consume when it's not coming from your own machine, but you still use it. So it is stored here on this company, they ask Fair Geographics, but because they have bought just the API or the service, they are consuming it as a service. Like this is an example of a service. It's an example of a link you are consuming. It gives you the image or the data you want, but you are not going to keep it on your own machine because sometimes it's heavy. But the city of Kigali also can choose to capture such information of a satellite image on their own database or their own servers. So that's another example. So let's say they have kept it on their server, but the only difference here you will see is that it doesn't go beyond from here. It's like for only Kigali. Another reason they bought what we call a service is because satellite images changes. If you capture today, next year it will be something new on this place. So you buy a service because you want to see updated information. So that's why you need mostly to buy what you call a service or an API from different sources. So this is one, the service as a satellite image. There is no other specific analysis they have done. It's just for us to visualize on the map. So if I still search for that area, Gikondo, I can still see it on the map. I can see buildings and other areas. So again, they have collected some data. What they call proposed zoning. So this is the work that was done by the GIS specialist. So they tell them, or they work with city planners, and they say, we want to divide this area of Kigali uh, into these regions. They want to keep the agriculture zones, they want to keep the commercial zones, they want to keep the mining parts. You see, the city has a lot of what they propose. So they work with city planners and decide, where are we going to keep agricultural zones? Where are we going to keep residential zones? Where are we going to keep the commercial zones from the map? So the work they do it manually. There's no data capturing. There's no area you can say this is a proposed zoning. Again, it's something proposed. It's not yet implemented. You are planning. So they capture the data by digitalizing. They decide this area, or they say the parcels falling in this area are going to be in the commercial zone. And the parcels from this side, maybe they're going to be in residential or somewhere else. Mixed use, yes, mixed use. So we have what we call the city commercial zone and the mixed use zone. So they normally do it manually, and then after a long time of working on it, they put it out, and we have it from their platform. So this is how they have captured the data. Again, we had also some other information on the list, which are parcels. So who can tell me how they have captured these parcels?
Georeferencing.
Right?
By georeferencing, digitization.
Yes. The same? So in Rwanda, when did we start to do mapping process? The how did we census? There was a census for collecting process that was done back in 2010. No. 29. Yes. So we have captured every person in the whole country. So they went on the field and they just asked someone who lived there, what is your boundary? And then they try to capture some information manually using the GPS. They call it GPS. It's something with high accuracy with capturing information. And then they go to the pitch court. Imagine visiting the whole country. So you have a lot of parcels in the whole country, almost 13 million. So after capturing those information, they have to store it in some database of servers, and then from there, that's how we can see information. And as you know, in the daily activities of people managing these parcels, we have the work of doing what we call subdivision, where someone sends a land and you have to fix the parcel which is already there. It's also done manually. They go on the field, they capture the new parcels from the ground, and then they put it together and then you find a way to present it from the uniform. So when you are talking about presenting, it is showing maybe choosing the color. And then the color of how this should be like, in case that it is black. And then the colors that we're seeing on this side, Start to use the application. So this is done in the country or more developed countries where they do surveys and then you try to put the data on the map. So I, mhm. So they take the paper, we put it on the scanner, we have it as a digitalized ticket. The PDF file. So when you have the PDF file, you do what you do with the reports. That's what they normally do. It's taking the data from the PDF and putting it into the ground. So now we know exactly the boundaries of those parcels. Some they call it ground points. So you say, for instance, I have a paper map for this parcel, and then you come and pass you want to point down the points, you take the call as a this area, and then you try to touch the paper of this area. That's what we say that so because they have a little parcels in the map, that's the only way we can do it. Is we digitalize it, are going to use the paper maps and then come again and use. But in addition to that, back then there was maybe not enough available to do it as simple as they could, what they wanted to do. But if they have paper maps, the only way you can do it is to do a geography. And geography is when you have a simple map and then you have what we call the ground points or the contour points. It's the ground contour points. This that you are very sure about. So we it's not really for depending on the area or what you want to utilize. You have the impacts of the negative it's the map. You can even make scratch for it so that you can see how it works, but that's how it mainly works. Let's give you an example of where JS is being applied. The second one was incident mapping. For instance, police is using GIS to capture where every incident is happening. So when you see police coming on any area, even an accident, they capture such information. So maybe when there is an accident or a car crash, and then they just come, they ask about what is happening, and they use their device to capture such information and then send it to their database, and then starts analysis for network. Most industries like give you example like Move, Vuba Vuba, Yebo, they are all using network, what we call network analysis. So it's network analysis is an analysis based on roads. So when you have roads and you have locations of where you want to go, they use such similar platform and then perform such analysis. We have site selection. For instance, if there is a new area they want to plan for, maybe industrial, park, conservation area, they use what we call site selection, depending on different criteria, and then they decide you can maybe set this location to be the one to do such practice. And even more like demographic, when we collect about the data about census, like the last one in 2022, they collected like everywhere where a house is located, so that they can count maybe the population of any area. So this is a broad topic. GIS is being used almost in every industry which needs to capture such information, and then from there they can do different analysis and then take decision from there. Lastly, on the last slide before we close, so the GIS is being evolving. We started with the desktop GIS, like the one we use here, using a laptop. It has moved to connect to servers as a standalone database site. And then from there, it has also evolved to web, where you can now access GIS content or consume services using a web platform. And now it is moving to the distributed GIS. So distributed, it means combining the three: desktop, server, and web. So you can't, if they say there is a web GIS, the web GIS as a final consumer, I'm just consuming content on the web. But the company providing such services, they are still using servers and desktop because they need to store such information. If, for instance, we take an example of Google, Google has somewhere storing such information, the satellite images, all the points of the ones, let's see, maybe in Kigali. So Google has a storage or a space where it keeps this information, either being the satellite images, either being these kind of points, information we are seeing on the map. They are kept somewhere, and somewhere it's just also a server or database storage where they keep such information. So what they do is to distribute such information so that someone who is using the desktop can access it. Someone who are managing the servers can still have privileges on those data. And then the end users who are consuming the content, we can still access those data, but using the web platform. So that's the chain of how it is evolving. And depending on the industry or what you're currently working on, you might have used maybe one of them, or you might be consuming like the WebGIS when you're using like Google Map. So this was the introduction. Before we are going out for a break, if you have any question on what we have covered so far, you can ask.
And another form of that I don't have the information.
We'll cover that in the last. There's different types of formats. There's the one you see, these are decimal degree units. There's also what we say as decimal degrees. When you're talking about images, we store them as rasters, as gridded data. We see different types of formatting. Any other question? So we are taking 15 minutes. So 15, yes, we take 15. We are back at 11:43, and then we will continue from there.
Now, what mention is
when you log into your account in the Google Classroom, I have uploaded the two content. The first one is the day one notes, and then the second is exercise data that we are going to use. So you can first download them, and for the notes, it's more detailed compared to the slides, but I also upload the slides for the one who wants to also use it. But the day one notes is more detailed, explaining everything we have covered. And because we are starting on before going to the next content, we are going to first have the software and the data. So you can be downloading the data first, and then I will show you when everyone is here how you're going to access the software. So everyone just download the data, and then for the software, you have two ways. So for the software, I have only two flashes. We're going to use them, but there's also another way of downloading using web platform. You can just have it in the bucket before Gives us. Let me show you another way of downloading the software. So go to your browser. And then type in ArcGIS.com. Enter. And then go to the sign in. Sign in. So I'm going to share you my credentials. I'm going to type in that way. But first copy them. Write them very well, because when someone just type in wrongly, they will give us 15 minutes to wait. So make sure you just type it as it is written. That's the username and the password. Or I can even copy it and maybe paste it in the WhatsApp group.
Yeah, that's it.
So just copy the name and then the password. So I've shared it on the group. This is the one in the WhatsApp group. If you have already learned this, that's great. Every time you type in very good. If you make it wrong, they will give us a like. The software, the flash, there's no need of passing through this. If you have already the software, it's the ArcGIS Pro. ArcGIS Pro. If you don't have it, and I have not given it on you on the flash, that's when you're going to use this platform.
Hello, June. Hello. Hello.
So
What about if I use the ArcGIS Pro, like the ArcMap, that doesn't need any license?
if you already know how to use it, it's okay for that.
I,
If
I
you have
have
the
it.
basic knowledge. Okay, that's enough.
I,
That's you can use
all
it.
right. Oh,
Let's move quick. So for those who have already logged in, okay. There's someone who have put it with the wrong password. Because you're all using the same, but the ones who are already logged in, let's see. We'll go here on my name and then choose my settings. My settings. So when you get to my settings, you will go to licenses and then there is an option of downloading. Okay. The settings and then licenses and then we download the ArcGIS code. Download the English version.
Yes, sir. Can you hear me? Hello? 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 Can someone hear me? Hello? Hello?
Hello. 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 No one. No one. No one.